want to thank everybody for taking the time out of their Thursday to join today to learn a little bit about how you can detect S3 breaches with Panther. My name is Jack Naglieri. I'm the founder and CEO of Panther Labs. I started the company back in 2018 after spending about 8 years as a security practitioner at Airbnb, at Yahoo, and before that at VeriSign. And during my time at Airbnb, I was the core developer of a open source project called StreamAlert, which is used for data analysis. And a lot of the lessons that we got from that project led into how we built Panther. So today I'll talk specifically around how you can use Panther for monitoring all the activity within your S3 buckets. So we'll start with a little bit of a background, and then we'll go into a deep dive on how these monitoring techniques work. There's a couple different options when it comes to looking at S3 data. So we'll talk about the two alternatives there. We'll talk a little bit about creating detections using Python rules, how to test them, how to do some research before we create these detections. And then to wrap the webinar up, we'll talk a little bit about improving cloud security posture on S3, some common checks you want to look for there, and then we'll end with some time for Q&A. So if you have any questions throughout the webinar, just feel free to drop it into the chat, and then I will get to them towards the end. But the goals for today really are, I want to teach you how to create these detections on data access for your buckets. And our goal really is just to always be informed on what's happening in our environments, especially when it comes to monitoring, sensitive user data, maybe financial data, or intellectual property that means a lot to us as a business. I also want to teach you how to really understand your security posture and how to fix a lot of low-hanging fruit that has historically caused a lot of damage for a lot of companies. And then I'll also walk through a couple of different ways of how to really search through this catalog of collected data in order to inform how we do our monitoring and improving our security posture. And before I dive into the more technical aspects, why should we even care about S3 monitoring in the first place? Well, for one, breaches continue to be an issue, even in the last couple of years. While S3 and Amazon have been around for quite a while, we're still seeing billions of records being leaked, and this is causing huge damages in user trust, and it's costing companies billions of dollars in fallout. So this was really the precursor for why we needed to build a product around this. So with Panther, we built a cloud-first solution, and our mission is really to stop security breaches by providing cloud-scale visibility. And when I talk about visibility, it really has to do with being able to collect and centralize all of the different security logs that we care about. And obviously, for the context of this webinar, it's really around looking at our CloudTrail data, looking at our S3 data, and then taking cloud security scan data that Panther can also collect, centralizing it, normalizing it, doing analysis with Python, and defining exactly what we're looking for in this traffic. We also store the logs in a data warehouse in a way that's very efficient, very partitioned, and sustainable over time. And then if our analysis finds any results, then we send it out to our team for triage, investigation, and then the whole cycle starts over again. We feed the output of our investigation back into our rules, and then we have more accurate and stronger rules. So I'm going to talk through all of these different pieces individually, but this is the end-to-end goal with Panther. Take in all of these different logs, make sense of it, and then tell our team when things go wrong. So coming back to S3. So there's two real options when it comes to understanding traffic. The first one is looking at CloudTrail. And CloudTrail is a service that monitors AWS API management events, like creating users, creating buckets, creating instances, things like that. But you can actually also configure CloudTrail to monitor object level events from buckets as well, instead of just the management events. The second option is S3 server access logs, which is a similar monitoring mechanism, but this provides a more detailed web style log on how objects are being accessed. And we'll go deeper into each of these approaches. So with CloudTrail, the biggest advantage here is that it's low latency, and it also has a lower configuration overhead and some additional filtering options as well. But the downside is that you have to pay for the data events that are collected in addition to the storage cost of the collected events. But with S3 server access logs, you only pay that storage cost. You don't have to pay for the actual events that are gathered. And then additionally, you get a more detailed log. So this is more of a web style, HTTP style log. So you can see the refers, you can see the total request time, the object size, and then you can craft slightly different rules on this data than you could with CloudTrail. You can also see authentication failures, transitions into Glacier, and other S3 storage types. The disadvantage here, though, is that it takes a little bit longer for us to get this log data, and the configuration is a little bit more involved. So the way that S3 access logging works is, let's say you have multiple source buckets. You can configure a setting on each of the buckets to point to an access log bucket. And all of this has to be from within the same region. So as you can imagine, if you have buckets across 5 or 10 regions, you need to have 5 or 10 access log buckets. And then you need to aggregate them all into a single place, in which case this is Panther. And if you look a little bit into how it gets organized in those access log buckets, we generally break it down with a prefix. So all of my bucket 1 logs would go into a bucket 1 prefix, etc. And then we can feed all of this in for analysis easily. But if we look at CloudTrail, it's a lot simpler. All we have to do is apply an event selector on our CloudTrail. And this, again, has a lot of different filtering options. So you could say, I want to look at traffic for this entire bucket. I want to look at traffic to only a specific prefix, or you can actually say, I want to monitor all of my buckets. So as you can imagine, this provides a much easier way to get going from the beginning. But the downside, of course, is that it doesn't have all the same rich context that we would need. So there's trade-offs to both. And generally, our advice is if you're very price sensitive and you operate at a high scale, S3 access logs are probably your best bet. But if you need really quick feedback on access to super sensitive data and you have a really large amount of buckets to configure, CloudTrail might work for you. But alternatively, you can actually just do a hybrid of both. So if you're very sensitive buckets, you can maybe turn on CloudTrail and server access logs for those. And then for the rest, you just use S3 server access logs by default. So let's go a bit deeper into what these logs look like and how we can create some detections. So in their raw form, S3 access logs, are a space-delimited web style log. And this, as you can imagine, would be pretty hard to write a rule against. But because we're sending it into Panther, we end up normalizing it into JSON, which ends up looking a little like this. So, now that we have these distinct fields, we can start to craft rules and we can start to look for certain activity. The thing I want to point out is that these fields that start with P underscore, these are fields that Panther adds during the normalization phase. So part of that is also, the IP addresses, and this could be other indicators such as domain names, SHAs, hashes, etc. So there's also some metadata around when the event was parsed and when the event actually occurred. So what I did is I actually set up a bucket that had CloudTrail and S3 access logs, and I did some activity, and then I measured to see what the latency difference was. So if you look closely, you can see the event time is actually the same, 21:42:46. But if you look at the parse time, which is the time that it actually got to Panther, we see the latency is very different. So CloudTrail latency is 5 minutes from event time to parse. And then S3 access logs, it's more around, the 40-minute mark. However, the S3 access log is telling us a little bit more about the HTTP status of the request. the amount of bytes transferred, the size of the object, and just some additional metadata that's not available in CloudTrail. So you could start to see, the differences in the types of rules that we're able to write. Which leads us into, how do we really think about writing these rules? I mean, generally what we want to know when it comes to monitoring any style of like network traffic is, who accessed our data, what data was accessed, and when did they access it? And then if we go a little bit deeper into how we write rules on this, it's, we want to model our known good traffic flows. We want to find any evidence of insecure access, meaning, non-SSL based connections to our buckets. And then we maybe want to look at errors to our buckets, which could indicate an attacker trying to enumerate their access or trying to get to sensitive data that they don't have access to. So let's dive a little bit deeper. And with Panther, we actually have open source rules that I'm going to be referencing throughout this webinar. So if you go to this bit.ly link, you can actually see the code that I'm referencing in these screenshots. So by default, Panther has a handful of S3 server access log rules built in. And also for this webinar, I'm focusing primarily on server access logs. A lot of this logic could be transferred very easily into CloudTrail if you wanted. Obviously, there's only certain fields available for S3 server access logs, but the same type of logic could be applied. What we do is we set up the rules in a generic sort of way. Obviously, everybody's environment is different. We use a tag on the rules called configuration required. And then you can actually go through and add the specific, IAM roles that you expect access from, or CIDRs and things like that. But one way you can actually get this information is by going to the Panther Data Explorer. So what you can do is, because this data is pulled into a data warehouse, you can run SQL on the data, and we use autocomplete as well to help you craft these queries. So in this case, I'm doing some basic research on my S3 access log data. And in this specific scenario, I'm going to look for unauthenticated access, which happens when there's no requester in the logs. So you can see every time I'm typing anything, it's doing auto correction and auto filling. And we'll use the output of this query to inform how we write our rules. So after I run my query, I get something like this. So I can see, the actual result. I can see that there's some really high volume of errors related to the head request, which is something that I probably don't want to look for in a real-time rule, just because it'll be super noisy. But if we want to look at, other errors such as, malformed requests, access denied, etc., on the actual objects themselves, this seems to be a more accurate and less noisy rule. So if we convert this into Python, we want to first limit, the status codes that we care about. And then, we can express all of this logic in Python quite easily. And that's actually one of the advantages of doing our rules language in Python. So we use the output of the Data Explorer to at least get an idea of what we've seen in our environment so far. And then we write our Python rule. And then we end up with a solid detection that will be grouped based off of activity within a certain bucket. That's what this dedupe function does. And then we also see interpolation based off of our buckets. So as an analyst, I can say, okay, we had, some suspicious errors related to one of our sensitive buckets. This is something I should look at. Or maybe you end up getting an alert to a bucket that's not as sensitive, and then you add it to a list and say, this actually isn't something I care about. But because we do all this in Python, you have a lot of flexibility in how these titles are generated, how the alerts are grouped, and things like that. So another scenario is, let's say we want to model traffic to our buckets from our application. So generally, you only ever want a certain set of IAM roles, or maybe only a certain set of instances to access our data buckets. And because we have this information with S3 server access logs, we can start to write a little bit more complex rules. So this is another example where we're doing known good traffic based off of IAM roles. So the requester field has these assumed role ARNs, and you can create these patterns where you say, okay, anything matching this bucket name pattern should only ever be accessed by these assumed roles. And these could also be users. It could be anything in AWS that is an identity. So it's users, roles, and some others. If you use federated users, etc. And all you have to do as the analyst is you just update this role mapping, and then you update your rule, and then it will start to take effect. And one way to increase the reliability and the confidence that this rule will actually fire is by using tests. So Panther has a built-in unit testing framework that just allows us to ensure that our rules are working. So you can actually copy these events from the UI itself. So whenever you get alerts, you can go and see the associated events, and then you can actually copy paste those events back into the rule itself, into the rule tests, and then make sure that these scenarios that we know are common are covered. And then if we want to do modeling based off of IP CIDRs, it's a very similar structure. So we have variables at the top of our rule, and all we need to do as the analyst is say, okay, this is the network of our VPCs, and these are the buckets that we want to ensure this traffic is only coming from. And you could also use the same type of logic if you want to make sure that caching is only pulling from your bucket. Or if you have a corporate network that's only accessing buckets, you can model all these different scenarios that are common to you. It's all based off of your own internal business logic. Another example is looking into insecure access. So if there's missing encryption on the buckets, this is something we want to know about right away. And this is actually enforceable with policies. So you can put a bucket policy that says, we want to basically deny any request that does not have encryption. But sometimes those policies are deleted, and the rule is essentially a defense in depth way of having a fallback in case the security controls actually are disabled. Which leads us into how do we think about improving our cloud security posture? So we have a lot of data to our disposal. We understand the activity in our networks, and that is really helpful. But sometimes we want to actually add controls in place on S3 buckets. So luckily, we have, along with our open source rules, we have a large set of open source policies that are based around CIS benchmarks and other security best practices suggested by Amazon and just in the greater community. And some of them are around similar concepts that I talked about today. So if we wanted to actually create a policy around bucket logging, we have that option by default. We can also ensure that our buckets aren't publicly readable. We can ensure that we have versioning enabled, which is important just for reliability and redundancy. And then we can also enforce things like secure access. So to give a demo of how this works, let's say that I'm going through and creating a bucket that has no security best practice applied to it. On the left side, I have Slack open, and I have Panther hooked up to Slack. So whenever we detect a insecure bucket, we'll go through and send you alerts, and you can actually optionally configure auto remediation as well. So the auto remediation is least privilege. It only has access to do very specific things on your S3 buckets. So I create this bucket, it's publicly readable, and it doesn't have versioning. It doesn't have anything that we would want in a really hardened and safe S3 bucket. So in a moment on the left side, we'll see some alerts come in because this is watching in real time. So it's about sub-minute latency. And then we see 4 checks that failed. And then we actually have automatic remediations hooked up to most of these checks. So as we start to see, as we go through the bucket, that now we have versioning enabled. And the next thing would be encryption. Now we have encryption enabled. And then now we have the public access block enabled. So you can see the power of real-time monitoring is really helpful, especially in things that have have the capability to cause a lot of damage. If we want to write our own policy, generally how this starts is we are given a resource, and this is a similar idea to a parse log. So we take a scan of all of the buckets, and then we pull that data back as JSON, and then we use that as input to our Python function. So this looks very, very similar to a rule. And what we can do is we can say, for this specific scenario, let's say we want to enforce KMS level encryption on all of our buckets, or maybe a subset of our buckets. We can write a policy that looks a little bit like this. And then if there's any buckets that are found non-compliant with this policy, we'll get an alert in Slack or PagerDuty or whatever we have set up. And then we'll be able to go through and understand a little bit of what happened. Or maybe it's a bucket that we want to add to an ignore list. So this gives you a lot of power. Again, using Python's extremely flexible. You can express exactly what you're looking for, and you can create these custom policies in the UI that we provide. So to give a little bit of a recap on what I've talked about today, we would suggest that you use S3 server access logs if you are sensitive to price and operate at a very high scale. But you can use CloudTrail to monitor your S3 activity as well with lower latency and a little bit of an easier setup. But the biggest takeaway really is just turn on logging as soon as possible. As an incident response team, you want to be prepared before an incident occurs, not in a scenario where an incident occurred and you have no data to back it up. So at a minimum, S3 server access logs can be a really good insurance policy that you could just set up today. And also, take care of your low-hanging fruit. Make sure that you have encryption, you have logging, you do all the security best practices, and then you start to monitor those hardened buckets, and you should be able to prevent most of the common breaches that we see in the headlines. And using Panther with this has a number of advantages. I mean, before, a lot of teams were very reluctant to send S3 access logs just because the scale could be very, very high, but we can operate at any scale. This could be 10 to 20 to 30 terabytes of data a day, even more. Another advantage with Panther is that we're using Python-based rules logic to both detect threats and vulnerabilities. We can be your centralized visibility layer. So you can feed in all of your security data through Panther, and you can write these rules to determine where you want alerts to go and how you want your team to really triage and investigate the activity that's happening. And then, we can also build these detection rules by using SQL with our Data Explorer. Our project is open source. So if you head to our Git repo, you can download and use a lot of the core functionality I talked about today. Our Data Explorer is a feature that is only available in our Enterprise Edition, as well as some other things around performance, gathering different log types, and a number of enterprise features like SSO and role-based access control. We also have a lot in documentation, and I'm actually going to be posting in the next day or so a lot of these SQL queries and code samples that I talked about today. But our docs will give you a really great way to get started on a lot of the concepts I talked about today. And if you're interested in running Panther as a SaaS, we do have a fully hosted platform available that has, again, these features that I just mentioned. We also offer 24/7 support for our customers and some additional analysis packs that aren't available in open source. And if you need to reach out to us, just email contact@runpanther.io. We also have a link actually in our docs for our Slack channel if you want to join and chat with us there. But otherwise, I will turn it over to Q&A. Okay, so first question from Georgios. On server access logs, can you see when someone downloads an object from your bucket and what that object was? Yes. Or do you need object level logging? So they're actually, by default, it is all object level logging. With CloudTrail, you actually can get more granular than that. But by default, there's no filtering with server access logs. And you actually can see if the person who downloaded it was authenticated or not. So generally the requester would be populated with one of those ARNs that I was mentioning. Let me actually see if I can find that slide really fast. Example data. If you see, let's see, does this have a requester? I don't think this specific one does because it was public, but you actually do get information on, so you can see the public IP, and this is actually my own, this is me, my public IP. You can see the full request URI, which is the get this GIF, and then you can see what time it was, you can see what operation I did. And then if I was an authenticated AWS user, then you would get an IAM role or some other information. Actually, on the left side, you can see there's an anonymous principal. So this is a non-authenticated request. Okay, question from Sanjay. Can we have auto response to alerts, like disabling public access on an alert? Yeah, so what you can actually do is you can use a policy for that. So for things that are infrastructure focused, you can create auto remediations in addition as a response, I mean, to the policy changing. Versus on the logs, it's more around detecting behaviors versus state changes in infrastructure. And we have a lot of these already predefined. So if you go to our docs, you can actually see the built-in list of automatic remediations. And if you have questions about that, you can reach out to us on our Slack, and I'd be happy to give you some more context there. Sure. Cool. If there's no other questions, and I think we can end there. And again, wanted to thank everybody for joining today. And I hope that this content was really helpful for you. And feel free to reach out if you need any additional clarification. Other than that, have a great rest of your day.